Hello Honors Geometry students, welcome back. Today's lesson is about how to find the volume of prisms and cylinders. And it goes along with our Learning Target 3G, how we can compute, solve, and analyze volumes of geometric solids. So we're still thinking about 3D objects. All right, and let's jump right into example number 1. It says, how many cubic inches are in a cubic foot? So when we talk about a cubic foot, we're talking about a cube, so length, width, and height are all the same dimension. Okay, and I'm drawing my two squares off center from one another, and then connecting their corresponding corners. So this is like 1 foot by 1 foot by 1 foot. To find the volume of this is 1 cubic foot. 1 times 1 times 1 is 1 cubic foot. But if I want to convert to inches, I need to convert each of those sides into inches. So 1 foot is really like 12 inches all the way around. So instead of doing 1 by 1 by 1, it's 12 by 12 by 12, or 1,728 cubic inches. So there are 1,728 cubic inches in 1 cubic foot. All right, cruising along. If we want to find the volume of any prism, remember a prism has two congruent parallel bases. So in this case of our figure, we have this lovely triangle across from this lovely triangle. So it is a triangular based prism. Our generic formula is big B times big H. Big B represents the area of the base. And if you tap on this link here, that's going to take us over to a Google Doc that I put together that summarizes all of our volume and area formulas that we will deal with in this unit and had dealt with in last unit. So all of our area formulas, like for example the area of a triangle, that's 1/2 base times height, that would be plugged in for big B. Big H represents the height of the prism. So my big H is the side that connects my two parallel bases. All right, so big B times big H. It might be tedious to deal with at first, but I would encourage you every time you see a prism and you're trying to find the volume, start with big B times big H because you are less likely to make a mistake. All right, so looking at this one, I'm going to consider this bottom piece my base, and that's a rectangle. So I'm going to replace big B with the formula for the area of a rectangle, which is length times width, and then it's times big height. So the length and width of my base rectangle are 11 and 8. The height of my prism is the piece that joins my two parallel and congruent bases, so my height is 10. So I have 11 times 8 times 10 for 880. And my unit is cubic centimeters because I'm thinking about how many cubes are going to fill up this 3D object. So I have 880 cubic centimeters here. All right, cruising along. Here I want to find the volume of the prism. I'm noticing that I have two parallel and congruent bases here. Okay, so I'm thinking about big B times big H, and I'm going to replace big B with the formula for the area of a triangle. So I'm going to replace big B with 1/2 base times height. All of that goes in for big B times my big H, which is the height of the prism. So it's very common at this stage in the game that we see a height and we want to stop there. Make sure you have the height of the triangle as well as the height of the prism. All right, so looking at this, I'm focused in on my triangle. I notice that I have 8, 8, and 8. So I have an equilateral triangle. So I'm going to redraw this guy. And we know equilateral triangles have 3 equal sides, but they also have 3 equal angles. And if I want to find the base and height of this guy, okay, I'm going to think about my 30, 60, 90 triangle, where across from 30 is x, across from 90 is 2x, and across from 60 is x root 3. Well, since the bottom edge is 8, I know each half is 4, so that makes my height of my triangle 4 root 3. So I'm going to plug in that my 1/2, my base of my triangle is 8, and the height of my triangle we just figured out was 4 root 3. Now I also have to plug in the height of the prism. So my big H is going to be 20, the side that joins together the two parallel bases. All right, I'm going to show you how to do this in 2 different ways, one as an exact answer and one as an approximate answer. All right, so if I want an exact answer, I'm going to multiply all the things not incorporated in the square root symbol. So 1/2 times 8 times 4 times 20, that gives me 320 times the square root of 3 cubic centimeters. Okay, so that's how an answer might show up on a standardized test like your ACT, something like that. All right, I also can do it as an approximate answer, and if I just type all of this stuff into my calculator, I get approximately 554.3 cubic centimeters. All right, cruising along. Now we're looking at the volume of a cylinder. A cylinder is not really considered a prism because the bases are not polygons, but it's still the same principle. The volume of a cylinder is pi r squared times h, so really it's just the area of the base. Base is a circle, so we're using pi r squared for big B, and then we have the height of our cylinder as well. All right, question number 4, we're going to find the exact volume of the cylinder. I need to know 2 different things. I need to know my radius, and I need to know my height. Well, looks like here my diameter is 12, so I'm going to cut that in half and get 6 inches for my radius. And my height is this piece here that would join together these 2 circular bases. Kind of have to imagine that hanging out in there, and I get 16 inches. If I plug it in, pi r squared times h, pi times 6 squared times 16. Okay, and I'm going to hit up my calculator. I'm going to type into my calculator 6 squared times 16, and that gives me 576 times pi, and I'm dealing with cubic inches. All right. So that's a quick run through of how to find the volume of prisms and cylinders. The homework for today is you're going to take a look at your textbook and read through the section, and starting on page 327, you're going to do 2 through only 30 because there isn't a problem number 32 even. All right, to get you started here, I want to point out question number 4. Sometimes I get questions about that one. So this is a cylinder, but it's kind of slanty. And so people are wondering, can I use my volume of a cylinder formula or can I not? Well, I want you to take a look at this picture of stacked quarters. All right, so the volume of metal that was used to make those quarters and stack them up is going to be the same if that stack is pushed over to the side like here, or if it's straight up and down, or if it's a right cylinder. So even though this stack is slanty, I can still use my volume equals pi r squared h formula. Think about what your radius is, okay? And then this 16 meters, that would still be your height. Looking ahead, question number 6 will be the same thing. You're still going to find the area of your base times the height of your prism. Okay, even though it's slanty, you can treat it the same way. The last one I want to just point out to you, question number 8, I see a regular hexagon. Sorry, somebody's drawn all over the pages in this textbook that I have. But remember, each angle in a regular hexagon is 120 degrees. So if I draw in my lovely triangle to find my apothem, because I know in order to find the area of this regular hexagon, I want to use the formula 1/2 ASN. I need to deal with this right triangle hanging out in here. I know the entire length here is 6, so it's split up into 3 and 3. And if I'm dealing with my pattern, across from 30 is x, across from 90 is 2x, and across from 60 is x root 3. So if x is 3, my apothem is 3 root 3. When I'm talking about my volume formula, I want area of the base times height. So keep in mind that you're going to be plugging in this 1/2 ASN formula in for big B, and then the height of my prism will join together my two hex bases. So this is the 9-meter side for my height. All right, please let me know if you have any questions. I will see you online. Bye.